Hi everyone, today I want to share about Thevenin theorem and Norton theorem. Thevenin's theorem. Case 1 without dependent source.
Yeah.
This is the example of the circuit for the case 1. First, we must to find RTH and VTH. First, find RTH. We must calculate the total resistor. Take out the first ohm resistor from the circuit and apply and do the Vasco formula to the circuit. For the voltage, we must short. For the current, we must open. The circuit will become like this. We must sum up the 6 ohm and 6 ohm resistor because the resistor in series circuit. So we must total up the 6 ohm resistor and 6 ohm resistor because the resistor in series. Then the circuit will be like this after the summation of 6 ohm resistor. The circuit will be in parallel circuit. So we must calculate the RTH. 1 over R equal to 1 over 12 plus 1 over 4. RTH is equal to 3 ohm. Second, we must find the VTH. The circuit will be like this. To the circuit, we use source transformation concept, which is 12 volt and 6 ohm. V equals to IR. So the V over R, V is 12, R is 6. We get 2M. So the circuit, we must put the 2A in ampere for the two current source. So the current source we will get 4M. Then the circuit will be like this. So after that, we use the source transformation concept to get the 24 volts like this. We get the 24 volt from this circuit. We use the source transformation concept by using 4M times 6 ohms. We will get 24 volts. So we must put the 24 volts like this in this circuit. So the circuit will become like this. After that, we must sum up the 6 ohms and 6 ohms because the 6 ohms in series circuit. So we must sum up and we will get 12 ohm. Before we want to find the I that's passed through to the 4 ohm resistor, we must to find the R total and the I total in the circuit. So we must do like this, which is 1 over R total equal to 1 over 12 plus 1 over 4. So the R total is equal to 3 ohm. We use the R total 3 ohm to find the I total. So we use the I total equal to V over R, which is V is 24 and R is 3. So we get 8M. After we find and we get the I total, we can calculate the I for ohm. Okay, nak cakap apa ni? The circuit, we can use the current divider to calculate the I flow through the 4 ohm resistor, which is the 4 ohm resistor and 12 ohm resistor in the parallel circuit. So we can use the current divider, which is we must take the value of 12 ohm over 12 plus 4 times 8, which is we get from the I total that we calculate. So the answer will be 6 amp. Then we can calculate the VTH. This is use the Ohm's law. V equals to IR. We can get the I from 6 amp times with I ohms. So we can get the 6 volt. Case 2 with dependent source. This is the example circuit for the case 2. From this circuit, we must to find Ix. Since this circuit have dependent source, so 1 volt must be added at the terminal A and B. So the circuit will be like this. The 6 volt we must short, so the circuit will be like this. Only this 5 ohm and 6 volt will short. So we must use the nodal analysis to calculate the V and the V1. First, we must find the node. So we name the first node is V and second node is V1. And then we do the direction of the current, and we can get the equation like this. For the first node, as we can see at the V, the equation will be negative V over 5 plus 1 over 5 times with V minus V1 over 3 minus V minus V1 over 3 equal to 0. So after we calculate, we simplify, we can get this answer. But we must assume the V1 equal to 1 volt. So we can get the answer, the final answer, which is V equal to negative 5 volt. For the second node, for V1, we can see the equation is I3 ohm plus I equal to I4 ohm. Then we do the equation like this: I equal to I4 ohm minus I3 ohm. But we must find the I4 ohm and I3 ohm. We can use the Ohm's law, which is V over R for the I4 ohm. V is V1. We put the 1 at the V1 over 4. Is the 4 ohm, and we get the 0.25 am. So for the I3 ohm is equal to the Ix. So we use V minus V1 over 3 because the Ix is from V to V1 over 3 ohm resistor. So we simplify and we get the negative 2 amp. After we get the answer for the I4 ohm, which is 0.25 amp, and I3 ohm, which is negative 2 amp, we substitute into this equation and we will get the I is equal to 2.25 amp. Then we can continue to calculate the RTH. RTH is equal to V over I. V we can get from this circuit, which is 1 volt. 1 over 2.25, we can get the RTH is equal to 0.444 ohms.
Betul.